There are a number of advanced and open issues in analogical reasoning that are the subject of current research. First, because analogical reasoning entails cross-domain transfer, does it mean that we necessarily need a common vocabulary across all the domains? Consider the example of the atomic structure in the solar system once again. Suppose I were to use the term revolves to say the electron revolves around the nucleus, but use the term rotate to say the planet rotates in an orbit around the sun. I have used two different terms. How then can I do alignment between these two situations? Should I use the same vocabulary? If I don't use the same vocabulary, what alternative is there? Second, analogical reasoning entails problem abstraction and transformation. So far we have talked as if the problem remains fixed, a source case is retrieved and transfer occurs. But often the agent needs to abstract and transform the problem in order to be able to retrieve the source case. A third issue in analogical reasoning concerns compound and compositional analogies. So far we have talked that given a problem, we can retrieve a case and transfer some knowledge from that case to that problem. But often we retrieve not one case and we transfer knowledge from not one case, but from several cases. If you're designing a car, you might design the engine by analogy to one vehicle and the chassis by analogy to some other vehicle. This is an example of compound analogy. But how can we make compound analogy work? In compositional analogy, analogy works at several levels of abstraction. Supposing we were to make an analogy between your business organization and some other business organization. We might make this compositional analogy first at the level of people, next at the level of processes, third at the level of the organization as a whole. This is an example of compositional analogy where mapping at one level supports transfer at the next level. How do we do compositional analogy in AI agents? Fourth, visual-spatial analogies. So far we have talked about analogies in which the transfer necessarily engages causal knowledge. But there are a large number of analogies in which causality is at most implicit. We'll consider these visual-spatial analogies later in the class. Fifth, conceptual combination. A powerful learning mechanism is learning a new concept by combining parts of familiar concepts. Analogical reasoning is one mechanism for conceptual combination. I have one concept, the problem concept, that of the atomic structure, another concept, the solution concept, the concept of the solar system. I take some part of the solar system knowledge, combine it with my concept of the atom to get a new concept of the atom. If you're interested in any of these issues, I invite you to join the PhD program in computer science.